Hey everyone, thank you for joining us today at this Alexia webinar. My name is Madan Kumar, Senior Solutions Engineer here at Alluxio, and today we're going to be talking about the path to migrating off MapR. Today, the uncertainty around the future state of MapR means that more and more folks are looking at alternative solutions to be able to offload their HDFS data. Today, that means a possibility of three different solutions. One is to move to a different Hadoop distribution, which in today's world is just Cloudera/Hortonworks. Move to a cloud offering that has HDFS in the cloud, such as an EMR FS in AWS, a Dataproc in GCP or HD Insight, or move to an object store, either on-prem or in the cloud. Today, because of the Hadoop ecosystem, what we notice is that compute frameworks such as Spark and Presto, while becoming increasingly popular, fundamentally cannot scale elastically if they are tied down to HDFS. Folks are realizing that HDFS is difficult to scale because of the complexity and cost that it requires. And so data in HDFS will ultimately have to move to a more optimal and cost-efficient system. And today, that solution is the object store. Object storage solves the problem of scalability at a fraction of the cost of scale-out file systems like HDFS. Economies of scale mean that it's also cheaper long-term than leveraging public cloud as data sizes grow. And finally, object storage still gives providers the flexibility of being able to deploy both either on premises or in the cloud. Alexia today offers a variety of different ways that could assist in migrating data off of MapR into an object store, whether that's in the cloud or on-prem. So today, Alexia could migrate to a cloud object store that's a HDFS or an S3 bucket, or it could also have the flexibility to migrate to an on-prem object store, whether that's an IBM, CleverSafe, or Swift Stack cluster. And the way Alexia does this today is that Alexia is built as a data orchestration layer for the cloud. Alexia gives you the flexibility that regardless of where your applications are running, that you could abstract away the underlying storage systems. And so one of the things that becomes apparent is that when applications start moving to the cloud, the underlying storage data migration becomes much more longer-term process to move from HDFS or to an object store. Alluxio, using its native under-storage drivers, actually provides the ability for applications to continue leveraging data as they're accustomed to while abstracting away the actual access patterns for the underlying storage system. So Alluxio uses a combination of what we call the northbound interface types to be able to speak to different application frameworks, and then southbound native storage drivers to be able to connect to a native storage system. Alluxio has three key innovations in this space that help with some of this hybrid architectures. One is the idea of data locality with intelligent multi-sharing. So this means being able to accelerate big data workloads by fundamentally bringing data closer to where the compute is actually sitting. So allowing compute frameworks to again have the ability to process, read, and write from data sitting in memory. Second is the idea of data accessibility. So for a lot of popular frameworks today that are used to an HDFS interface type, when they move to an object store, there's changes in terms of how metadata is operated and how data is accessed that are not as efficient. With the API translation, Alluxio actually translates APIs from the native interface type, whether that's HDFS for a lot of these big data frameworks, natively to the underlying storage system of their choice, which is an S3 interface type. And then finally, the idea of data elasticity. So as folks move to the cloud, one thing becomes apparent in that compute is now elastic. Storage is also more elastic with things like S3 and EMR. But the one thing that still remains inelastic is data, because data still needs to get brought over and migrated from different subsystems. Alluxio gives you the ability to now also enable data elasticity along with your compute in these cloud and hybrid environments. So next, I kind of want to just show you guys a quick demo of how we can enable some of this migration in Alluxio and what are the features Alluxio provides to be able to access data from different underlying storage systems. So in this environment that we set up with Alluxio, Alluxio has two what we call mount points. The first being an AWS S3 bucket, and the second being an HDFS cluster. And on top of that, we're leveraging Hive as the analytic framework or the computational framework of choice. And to take a little bit better understanding of what this looks like through the Alexia command line, let's just go into the Alexia cluster here and go ahead and pull up what we call the Alluxio command line toolkit. So by doing Alluxio FSLS, what we see here are multiple subdirectories mounted into the Alluxio namespace. And the two directories I want to point out distinctively are HDFS and S3 buckets. So today, HDFS is being mounted as a separate subdirectory within Alluxio, and we also have different S3 buckets available to us as well. The way that data movement occurs within Alluxio is that we can map HDFS tables to a certain Alluxio file location. So assuming that a table already exists in HDFS and HDFS is mounted as a root underscore, you can move in internal tables from Alluxio to an Alluxio file location as follows. So if I go ahead and actually bring up my Hive console here, and just to kind of show you guys that there is an HDFS cluster running here as well, we can do an HDFS LS. And we notice that we have different directories as part of this HDFS cluster. The HDFS cluster that we mounted into Alluxio is going to be the /user/hive directory. So if we go to /user/hive, we see that it's a warehouse directory, and that's actually the directory that we mounted into the Alluxio file system. And to verify that, we can also check through the Alluxio file system here. And you'll notice that it has the same warehouse directory that's actually currently mounted in HDFS today. So if I go into Hive and go take a look at this table that's now currently being persisted in HDFS, we can understand kind of from a table perspective what application changes are needed for Alexia to be able to leverage it. So I went ahead and created a sample table here called u_user HDFS. And this table currently today is being persisted and located on the HDFS cluster, as you can see here by the external file location. So today, this is HDFS against the user/hive warehouse database. However, since we did mount this, since we did go ahead and mount this directory into the Alluxio file system, Alluxio now has access to data through the Alluxio command line as well. So if we go ahead and look at the /data warehouse, we can actually see that the file that's being used for this data is now not only persistent in HDFS, but also 100% in Alluxio memory. So once we have tables in Alluxio mounted, we have the option of letting the tables exist as an external table in HDFS, or altering the table definition to be stored against the Alluxio file location. For the time being, let's just assume that we'll keep the table as is and let it be persisted on HDFS and stored against the HDFS file location. One thing to read is to understand as well, however, is that what we see here is that on first time reads, data is going to be fetched from the underlying source system. So this means cold reads of data because it's a remote fetch. On every subsequent read, if the file and data for that particular table is already in Alluxio memory, reads are now going to be happening from the Alluxio cache instead of going out to the HDFS file system. So now we want to go ahead and create a table against the S3 file location. So we can go into Hive. And we're going to go ahead and create that same table in S3. Now, so now that we created this table against the S3 file location, one thing to understand is right now this table doesn't have any data as part of the table creation. So if we go ahead and do a select against this table, we should of course expect to get 0 results back from this table. Now, to migrate the data into the S3 file location, all we could do through the Alluxio namespace is do a simple CP command from the HDFS file location to the S3 underscore. So you can leverage the Alluxio copy command to copy a file or directory from the Alluxio file system or between the local file system and other Alluxio file system storages. So in this environment, what we're doing is using the Alluxio cp command to copy files from HDFS, which we mounted into Alluxio, to the S3 location, which we also mounted into Alluxio. So this above command is going to copy the files belonging to the user table on HDFS to the table that we have now created against S3. Allocation, please. Okay. Okay, that did it. Okay, so now that we went ahead and copied that file into the Alluxio table location, let's go back and spin up our Hive cluster and Hive CLI, and again do a select against that file, against that new table we created. Now, again, remember, this table is actually being created against S3 with data being persisted in S3 storage, and we can see that by doing a show create table. Okay. And this is actually being persisted against the S3 file location. So now when we go ahead and do a select source from the underscore table S3, we now see that that result set is now copied into the S3 file location. And so using a simple Alluxio mount command to mount two disparate storage systems into Alluxio, and then doing Alluxio's cp command to copy files, we now have the ability to migrate certain data files through the Alluxio namespace from a HDFS storage into an object store. One thing to keep in mind is that the capabilities Alluxio offers here is that while migrating data, you want to enable end users and analytics and analysts to be able to leverage the same data access patterns that they're accustomed to. So regardless of where data sits on MapR today or it's moving to an object store tomorrow, end users still need self-service access to the data. Alluxio provides that capability while not having to worry about the underlying migration of data from disparate storage systems. So through Alluxio, you're able to more seamlessly move data off of HDFS into the object store. Allows end users to continue to access the data without waiting for data migrations to complete. One thing to keep in mind as a consideration, though, is when we talk about migration from the Alluxio perspective, migration is really meant as and when needed by the application. So in this case, as Hive or Presser or Spark users request a subset of data, we want to ensure those data sets that they're requesting most frequently are made available to them through Alluxio. For migrations in the petabyte scale, we still recommend solutions like a Snowball or hard drive Snowball device from AWS or something similar to be able to migrate those petabytes of data from HDFS to an S3 or an object store. Now 2.0 release, Alluxio also has policy set where we can do limited data movement on demand or by policy. Next, I just want to kind of briefly run through a few slides of what the Alluxio architecture looks like from a high level. So as a reference architecture point, Alluxio follows a very similar architecture to HDFS, and that's a master worker client architecture. As a best practice, what we see here is that typically Alluxio workers are processes that run co-located to where the application is running. So whether that's a Spark or Presto application, Alluxio workers be co-located and local to those processes. And the reason is that we want to allow these applications to have no local reads and writes of data, which is possible through the Alluxio workers and their local cache. Alluxio also has high availability built in through either Zookeeper, if you have an external Zookeeper, or in our latest release, we actually use an embedded internal Raft election algorithm to be able to roll over to a standby master. And of course, here we see that Alluxio has the ability to mount those disparate storage systems into the Alluxio namespace. So the Alluxio daily access to a global namespace, what that looks like, and we kind of saw a little bit of this in the Alluxio FS command line, but fundamentally you can mount certain storage systems into different directories, and that directories and access is abstracted to the end user. So regardless of where data is sitting, users could continue leveraging it as they're familiar and accustomed to, and would just have to kind of change the external file location that they're now querying against, which would be the Alluxio master file name. You have a couple of different ways to interact with data, and so within Alluxio, and so you have a variety of ways to both be able to read and write data with multiple different options. And so when reading data, you could read data directly from an HDFS or object store, where the data is not sitting in Alluxio cache, or you could read from Alluxio cache and on one of the workers that has a subset of data cached locally, or you could read from multiple different Alluxio workers in tandem. When you write data from the application to Alluxio and to the underlying understore, you could write data only to the Alluxio tier. You could write data only to the understore, and then you have options to both synchronously and asynchronously write between the two. Alluxio also gives you the ability to write to Alluxio and then replicate to multiple other workers when you need higher SLAs or high availability built in for data assurance. A few folks today that we see are leveraging Alluxio today. And if you're interested, you can join our open source community and join our conversation on alluxio.io Slack. And yeah. Would like to open the floor up to any questions, if there are any at this time.